Welcome back to Talk Tensors. Today we're going to be taking a deep dive into this paper called Course-Defined Cue Network with Action Sequence for Data-Efficient Robot Learning.
Catchy title, huh?
Yeah. So, the core concept here is all about how do we teach robots to think in sequences of actions instead of just like single individual movements.
Yeah.
Like we as humans, we plan things out in our heads. Right. We don't think about like, okay, move this finger, then this finger.
Yeah, you don't think about every muscle you're activating when you reach for a cup of coffee or something like that.
Exactly.
You're just thinking, I want coffee.
Right. It's like, I want coffee, and then your brain figures out the rest. So can we give robots that same kind of like high-level planning ability?
Well, and that's where this paper comes in, right? It's exploring how to give robots that ability to think more holistically, in broader strokes.
And why is that so important? Why are we so focused on making robots think in sequences?
Well, traditional robot learning methods, they kind of hit a wall when it comes to the complexity and noise of real-world data. It's like, think of it like trying to learn a recipe from a really chaotic cooking show, right? There's so much going on, it's hard to isolate those crucial steps.
Yeah.
But if robots can learn to think in sequences, they might actually be able to master those complex real-world tasks we've always struggled to teach them,
Okay, so let's break down how they actually approach this in the paper.
Okay.
They introduce this new algorithm called CQNAS, and it builds on this idea of something called Course-Defined Cue Network, or CQN for short.
Right. And CQN, the way it works, it's almost like zooming in on a map.
Okay.
You start with this broad view, and then gradually you refine your focus until you get down to the nitty-gritty details.
I see.
So CQN breaks down these continuous actions into progressively finer bins, you could call them, right? So it's like you're narrowing down the possibilities with each step.
Okay, and then CQNAS, it takes this concept a step further.
Yes, exactly. It adds in the action sequences.
So instead of just focusing on one tiny movement, one little bin at a time, it looks at a whole series of actions, right?
Exactly. And it uses something called a critic network to evaluate the long-term consequences of those sequences. So it's kind of like having a coach, right?
Yeah.
A coach who can tell you if a particular dance routine will lead to applause, or maybe you'll trip and fall on your face.
Okay, I like that analogy.
Yeah, it's all about predicting the outcome of a sequence.
So before we jump into the nitty-gritty of the results and all that, I think it'd be helpful to understand the research landscape that led to CQNAS. What were the challenges that researchers were facing that led to this kind of approach?
Yeah, absolutely. So the field of robot learning has been, struggling with this problem of data efficiency for a long time. Traditional reinforcement learning methods, where robots learn through trial and error, they require massive amounts of data, and often the movements they come up with are kind of unstable, or unrealistic.
Yeah.
So researchers have been searching for ways to streamline that learning process, make it more efficient, make it more robust.
Okay, so there's been this drive to be how can we make robots learn faster, basically?
Exactly. And there have been some interesting developments along the way, right? Like imitation learning, where robots learn by watching demonstrations that showed some promise. But often those methods, they fall short when the robot needs to adapt to new situations,
Yeah, they can mimic, but they can't really generalize.
Exactly.
So is it fair to say that this idea of teaching robots to think in sequences, like CQNAS does, is it sort of a natural progression of these previous attempts to improve data efficiency?
Yeah, you could say that. It definitely builds on those earlier ideas. And, even CQN itself, which CQNAS is based on, that was a significant step forward in that direction, right? Breaking down actions into these increasingly fine bins, that helped robots learn more efficiently and with greater precision.
Okay.
But CQNAS takes it further with the addition of those sequences, right? That's what really sets it apart.
Yeah. Yeah, that seems to be the key innovation here. Okay, so we've kind of set the stage now. We understand the problem. We understand how CQNAS tries to solve it. Let's dive into how this new approach actually performs, put it to the test. The researchers tested CQNAS in a variety of different simulated robotic environments, and one of those is called Bidgem, which is designed to test a robot's ability to manipulate objects with two arms, kind of like in a kitchen setting.
Right. So think picking up cups, moving plates around.
So we're talking about robots learning to cook. That's kind of amazing, but also maybe a little scary.
Yeah, maybe a little bit. I don't think we're quite at the point where robots are going to be winning cooking shows or anything like that.
Yeah.
But the results they're pretty impressive. So In this BIGIM setting, CQNAS was actually able to learn these pretty complex tasks, right? Like moving plates, loading a dishwasher, even flipping a sandwich.
Wait, flipping a sandwich?
Yeah.
That's impressive. That takes some serious, like, dexterity and coordination.
Yeah, it does. And you said it learned these tasks more efficiently than previous methods.
Significantly faster, yeah. It seems like thinking in sequences allows the robots to grasp the underlying structure of these tasks more quickly. So that leads to faster, more effective learning.
Yeah, that's really promising, isn't it?
So it did well in the kitchen. How about other scenarios?
Well, they also tested it in Humanoid Bench. So Humanoid Bench focuses more on humanoid control tasks. So things like walking, running, navigating obstacles.
So more parkour than cooking this time.
Yeah, kinda. You could think of it that way. And again, in this setting, CQNAS outperformed existing methods, especially when the tasks got more challenging, you know? The more difficult it got, the more CQNAS seemed to shine.
Okay.
That suggests that this algorithm's ability to plan sequences, it's valuable across a variety of robotic domains, right? It's not just about fine motor skills, it's about that high-level planning.
Yeah, it's a fundamental advantage, it seems like. But did they only test it in these simulated environments? Or did they also try it out in the real world?
They did. They also evaluated CQNAS on RL Bench, which is a benchmark that uses synthetic demonstrations. So it's not quite the real world, but it's getting closer. It's for tabletop manipulation tasks. Now, on RL Bench, CQNAS performed comparably to CQN. So it wasn't always the absolute top performer,
Okay.
but it still showcases the algorithm's versatility, you know? It can handle a variety of challenges, which is pretty remarkable.
Yeah, it's not always the best, but it's always up there, which is still pretty impressive.
Right.
It sounds like overall CQNAS is a significant step forward for robot learning, right?
Right.
But did the paper delve into any potential limitations or areas for improvement?
Yeah.
You know, because no algorithm is perfect, right?
Right. And this is where it gets really interesting, I think. Despite all these successes, CQNAS actually struggled with something called torque control.
Now, for those of us who aren't robotics experts, what exactly does torque control mean?
So torque control is all about specifying the force a robot applies, right? Not just its position. So imagine trying to open a jar. It's not just about the movement of your hand, it's also about how much force you exert.
Right.
CQNAS, it seems to excel at planning these sequences of positions like where the robot's arm should be.
Okay.
But when those sequences need to incorporate specific forces, that's where it seems to struggle.
So it's like it can plan the movements really well, but it has trouble figuring out how much force to apply during those movements.
Exactly. It's almost like it's fluent in the language of movement, but it struggles with the dialect of force.
I like that. That's a good analogy.
Yeah, it highlights that even with these advancements, there's still so much we're learning about how robots actually learn and interact with the physical world. You know, forces are tricky.
Yeah, forces are a whole other ballgame.
Yeah.
So even with this, breakthrough, there's still so much more to uncover. Okay, so before we move on to our, novel notions segment, are there any other key takeaways from this part of the paper that stand out to you?
Yeah, I think it's worth emphasizing the importance of the ablation studies they conducted, right? So ablation studies, these are experiments where they essentially remove or alter certain aspects of the algorithm.
Okay.
And this helps them understand what contributes most to its performance.
So it's like taking the algorithm apart and seeing which pieces are really doing the heavy lifting.
Exactly. And one of the things they found is that longer action sequences, generally speaking, they lead to better performance.
Okay.
This reinforces this idea that, robots benefit from thinking beyond just individual actions, thinking in broader strokes.
It's like if you're going on a road trip, right?
Yeah.
If you only focus on the next mile, you might miss the bigger picture and get lost.
Exactly.
You need that overall plan, that roadmap.
And they also highlighted the importance of the reinforcement learning objective itself. They really emphasized that robots need to learn from their own experiences, their trials and errors, rather than just imitating demonstrations.
So it's like you can watch someone ride a bike all day long, but until you actually get on the bike and feel the balance yourself, you won't really learn how to ride it.
Exactly. You need that firsthand experience.
Okay.
And they also introduced this neat trick called temporal ensemble. And temporal ensemble, what it does is it helps smooth out the robot actions. So imagine a choreographer refining a dance routine, right? It's all about finding the right flow, the right timing.
So it's like adding a bit of grace and fluidity to the robot movements.
Mm.
That's interesting. But I guess there are times when you might need a quick reaction, right? Like if something unexpected happens and that smoothness might actually hinder the robot's ability to respond quickly.
Yeah, exactly. So while temporal ensemble is beneficial in a lot of cases, it can sometimes slow down reaction times when speed is paramount.
Yet it's a trade-off. So even with these techniques, it's about finding the right balance,
Yeah.
right? Adapting to the specific situation.
Precisely.
Cool.
There's no one-size-fits-all solution in robotics.
Well, it sounds like we've covered a lot of ground already. From the limitations of traditional robot learning to the nuances of CQNAS and, the potential for improvement. This paper has certainly given us a lot to think about.
It really has.
And I'm actually really intrigued by this potential of combining CQNAS with other emerging trends in AI, particularly something called vision language action models, or VLAs. I know we're going to talk about that more later on.
Right, that's where the novel notions come in.
Exactly, but we'll save that for later. For now, thanks for listening to this part of our deep dive into the world of robot learning.
Yeah, stick around for more.
We'll be back in a bit.
To explore those exciting possibilities of combining CQNAS with VLAs, it's going to be a fun ride. So, before we went to that little break, we were talking about the potential of CQNAS and kind of like where it could lead us in the future of robotics.
Right, and you mentioned these vision language action models, VLAs.
VLAs,
That
yeah.
sounds like, I don't know, something out of a sci-fi movie. What are they exactly?
Well, they're really fascinating. They're this new class of models that can understand and then act upon information from all these different sources.
Okay.
Images, text, even physical demonstrations. So they're like the ultimate multitaskers of the AI world.
So are you saying we could potentially have robots that, I don't know, learn not just from watching other robots or human demonstrations, but like from things like instruction manuals or even like YouTube videos?
Exactly. Imagine a robot that could learn to assemble, I don't know, a piece of furniture just by watching an IKEA instruction video, right?
Yeah.
Or a robot chef that masters this new recipe by following along with a cooking show.
That's wild. I mean, that opens up like a whole new world of possibilities for robot learning. It's like giving them access to this vast amount of knowledge that we humans have already, accumulated over the years.
Right, and that's what makes this idea of combining CQNAS with VLAs so intriguing. We could potentially see this huge surge in robot capabilities,
Mhm.
enabling them to adapt to new tasks and environments really, really quickly.
Yeah, because it's like they're constantly learning and expanding their repertoire of skills just by observing, processing information from the real world, just like we do.
That's the idea, yeah.
Of course, this is all still pretty speculative, right? We're talking about combining like cutting edge technologies in ways that haven't even been explored yet. So it's like it's a lot of potential, but
Right, it's still early days.
yeah.
We're in the what if stage, not the when stage yet.
But that's what makes it so exciting, right? We're
Yeah.
venturing into this uncharted territory. So what kind of research directions do you think this could lead to if we were to, really start exploring this combination of CQNAS and VLAs?
Well, for starters, we could start by fine-tuning those existing VLAs with CQNAS, right? So we give them the ability to learn from an even wider range of data sources. We could also try to design completely new VLA architectures that are specifically, tailored for sequential decision-making in robotics.
So it's like giving robots this whole new set of tools for learning, for understanding the world around them.
Yeah, and while there are definitely going to be challenges, as with anything new, the potential benefits are huge. I mean, we could see robots that are far more adaptable, more versatile, capable of working with us, with humans, in entirely new ways.
It's a really exciting prospect. Before we, wrap things up completely, are there any other like thoughts or reflections you have on this whole paper, the future of robotics in general? I mean, we've covered a lot.
Yeah, I think it's important to remember that even with all these advancements, robots are still tools at the end of the day.
Right.
They can augment our capabilities, they can help us solve complex problems, but they're not replacements for, human ingenuity and creativity. We still need that.
Yeah, that's a crucial point. It's not about robots taking over. It's about finding ways for humans and robots to work together, to collaborate, to complement each other's strengths.
Exactly. And as we continue to develop these, increasingly sophisticated algorithms like CQNAS, we need to always consider the ethical implications. We need to make sure that these technologies are being used responsibly and for the benefit of everyone.
I think that's a perfect note to end on. This paper has given us a lot to chew on, from the specifics of how robots actually learn to the broader implications of, AI and its role in our future.
It's a lot to think about.
It is. And it's clear that robotics is advancing at an incredible pace. I mean, it's mind-blowing to think about what might be possible even in the next few years.
It's a really exciting time to be working in this field.
Absolutely. So thank you so much for joining us today on Talk Tensors for this deep dive into the world of robot learning. We hope you found it, informative, thought-provoking.
Yeah, we hope you learned something new.
And we hope you'll join us again for our next exploration of, cutting-edge research in AI.
Always more to discover. There's always more on the horizon.
Exactly. Thanks again for listening.
See you next time.
It's really amazing to think about how far we've come with robotics, and where it's all headed. This paper really highlights that shift from robots just blindly following instructions to actually learning and adapting on their own, like figuring things out for themselves.
It really is. It's remarkable. This whole idea of robots thinking in sequences like we do, it just opens up a whole new world of possibilities for how they interact with the world around them, how they learn from it.
Yeah, and those novel notions we talked about, combining CQNAS with VLAs, that could be huge.
Oh, yeah, definitely.
I mean, that could potentially change everything about how quickly robots can learn new skills. Just imagine a world where robots are constantly learning from this massive amount of information that we humans generate every single day. It's like this constant feedback loop of learning.
And it wouldn't just be from, watching other robots or even human demonstrations.
Right. It's from everywhere.
It could be from YouTube videos, instruction manuals, all sorts of things.
Exactly. It's like drinking from a fire hose of information.
And I think it also highlights the importance of collaboration between these different research areas.
Oh, yeah.
Robotics is not in a silo.
Yep.
The advancements we're seeing in robot learning are often fueled by breakthroughs in other fields like computer vision, natural language processing. All of these things are interconnected.
It's like all the pieces of the AI puzzle are starting to come together now, and it's creating this much more complete and powerful picture,
Yeah. And as we push the boundaries of what's possible with AI and robotics,
right?
We have to remember the bigger picture, the societal implications.
The ethics, yeah.
We need to ensure that these technologies are developed and used in a way that benefits humanity, We have to be mindful of that.
Yeah, it's a responsibility that we can't, take lightly. But I do believe that if we're careful, if we focus on ethical development, robots have the potential to make our lives easier, safer, more fulfilling.
Absolutely. It's an exciting time to be working in this field.
Yeah, for sure.
I can't wait to see what the future holds.
Well, on that note, I think it's time to wrap up our deep dive into CQNAS.
Yeah.
We've covered a lot today.
We have.
From the, the nuts and bolts of how robots learn to the mind-blowing possibilities that are just around the corner,
Yeah, it's been a pleasure talking about all this with you.
Likewise. And for our listeners, if you want to explore this paper in more detail, we'll have a link to it in the show notes.
Yeah, check it out.
Until next time, keep those algorithms hunting and those robots learning.
And remember, the future of AI is in our hands. Let's build it together, responsibly and thoughtfully.
Couldn't have said it better myself. Thanks everyone for listening.
We'll see you next time on Talk Tensors.